In this video, we're going to talk about rational expressions and equations. Okay, so rational is a fancy word for fraction, like a divided by b, fraction there. So in these problems, a rational is defined to be r of x, to be a polynomial q of x divided by another polynomial, polynomial p of x divided by some q of x. And then values that we exclude x values where q of x is equal to 0. Okay? Why? Because that old famous rule, right? Thou shalt not divide by 0. Cannot divide by 0. Just can't do it. Right? It's undefined. Right? Dividing by 0 is undefined. So we got to avoid it. So we got to figure out, sometimes for us it's easier to figure out what not to do, okay, and then avoid that than it is to figure out all the things that we actually can do, okay? So let's start with an example. I want to simplify, and then I want to write the values of the variable that must be excluded. So your problem, 6 divided by 5x. Okay, now first thing I do is I try to simplify. I factor. Okay, I factor the top, I factor the bottom. Now 6 in the numerator, there's nothing that factors, it's just 6. 6 times 1, right? 5 in the denominator, 5 and 6 have nothing in common. They're relatively prime to each other. Now, we see that there's nothing that can be done, so this is reduced as much simplified as you can. So this is just our answer. What I do once I have this part here is I'm going to set it equal to 0. Set the denominator equal to 0. Okay? So set the bottom equal to 0. What's the denominator here? It's 5x. So 5x equals 0. Divide by 5, divide by 5. If you don't believe me, type it in your calculator. 0 divided by 5 is 0. X equals 0 is a restricted value. You will be asked to write out the restricted values. So x equal to 0 is restricted. Okay? Why? Because if I plug a 0 in here, it becomes 5 or 6 over 5 times 0, which is 6 over 0, which is undefined. Can't do it. Okay? Can't do that. Excuse me. So those are the restricted values of x. All right, so let's try another one. X minus 2 over x plus 3. Okay? Step 1, what I want to do, all right, is I want to factor. Can I factor anything? Okay? So factor. Step 1, step 2, set the denominator, the bottom, equal to 0. Step 3, simplify. Okay, so those are your 3 steps. Now, here, there's nothing we can do. I see some students that get all creative like, and they'll say, oh, that x cancels that x, but that's a big old no-no. Those things do not cancel out at all, okay? They are factors. X minus 2 is one factor. X plus 3 is one factor. So neither the top nor the bottom can cancel with anything, all right? So this is the answer, x minus 2 factored over x plus 3 factored. Now, what do? I set the denominator equal to 0. That's x plus 3. So if x plus 3 equals 0, subtract 3, x cannot equal negative 3. Okay, so restricted value of x is -3. Okay, if I plug in a -3, what happens? I end up dividing by 0 in this expression here. Okay, and that's what I want to avoid. Let's try one where, we might actually use something. All right, 3y over 5y squared minus 2y. Okay, so what? Well, the numerator is factored. It's 3 times y. But the denominator, we've got two terms, and it looks like there's a y in common between the two, so GCF. If I pull a y out, what do I have? I have 5y minus 2. Okay, 5y minus 2. All right? Now, before I simplify, what do I have to do? I got to set the denominator equal to 0. What's the denominator? It's this piece right here. So I got to set that equal to 0. Y times 5y minus 2 equal to 0. If I do that, that means either y equals 0 or 5y minus 2 equals 0. So y equals 0 is a restricted value. And then plus 2 gives me 5y equals 2. So y equals 2 over 5 is another restricted value. So those two are restricted values. Now I can go one step further. What else do I know? This y, I can cancel with this y here. Now why can I cancel here, but I couldn't cancel up here, right? Well, what's the big difference? This is multiplication holding those two together, right? When multiplication holds them together, then I can cancel. Here it was subtraction and addition, which was holding these two pieces together. That's why we couldn't cancel. All right, so big difference there. So what does this become? It becomes 3 divided by 5y minus 2. As long as y is not equal to 0 and 2/5. Okay? So that's just as much as part of the answer as the simplified version right here. Okay, so make sure you get not only the simplified version, but that you write the values of x or y or whatever the variable is in which you must exclude. It must be restricted from the domain because we cannot divide by 0. Okay? Next example. Now, you might be asking yourself, now why didn't I just simplify here? Had you simplified this first before you set it equal to 0, you would have had 3 over 5y minus 2. And then when you set the denominator equal to 0, you would have just gotten the one restriction. But this one would have been forgotten. It would have never been found, right? So that's why we don't simplify before we set the denominator equal to 0, because we want to find all the restricted values, okay? All right, just thought that might be one important thing to note. Okay, x squared, moving on. X squared plus x plus 1 divided by 4x squared minus 2x, okay? Interesting. Now the denominator factors, okay? It factors, I can pull an x and a 2 out of each of those. So 2x comes out, and so that leaves me 2x minus 1 inside. Okay, what about this top here? AC method might help me. Let me see. So if I do the AC method, I want it to multiply to 1 and add to 1. Ooh, 1 times 1 gets me 2. -1 times -1 gets me -2. Huh, that's weird. So it's impossible to factor the numerator. So the numerator is x squared plus x plus 1. And since we don't see that factor down low, then we can't do anything to simplify this anymore. Okay, so this is simplified as much as you can do. And now I can set the denominator equal to 0. So 2x minus 1 times 2x equal to 0 tells me that 2x equals 0 and 2x minus 1 equals 0. So that means x equals 0, so that's a restricted value. And plus 1 2x equals 1, divide by 2, x equals a half. That's another restricted value. So this is true as long as x is not equal to 0 and not equal to 1/2. Okay? Next up, x squared plus 5x minus 6 divided by x squared plus 4x minus 5. Now, you're going to run into a lot of these trinomials, and trinomial T-chart AC method is kind of a headache. If you know that the 1 is in front, that's the a is equal to 1, there's a trick, okay? There's a trick to help you factor this quicker, all right? So let's start with the numerator. Okay, so this multiplies, AC method says multiplies -6, adds to 5. Now, if you multiply to -6, add to 5, let's see, 2 times -3 gets me -6, but that's -1. 6 times -1 gets me -6, and 6 minus 1 is 5. So that's what I'm looking for, 6 and -1. Now the 6 and -1 here, the trick is this. If a equals 1, and only if a equals 1, can this trick work, guys. Don't try to do this if I have like a 2 or a 3 or 4 or whatever. It only works for a equal to 1, okay? So if a equals 1, what's the trick say? It says this plus 6, this positive 6 here, means I have x plus 6. And then this -1 here means I have x minus 1 as a factor. Now, if you don't believe me, you can walk through this. X squared plus 5x minus 6. You could do x squared and then plus the 6x minus the x minus the 6. GCF. Factored by grouping, x plus 6, and then pull out the -1, x plus 6, then x plus 6 times x minus 1. Lo and behold, it's the exact same thing. So if you're, like me and you like to do the same thing every time, you can do the same thing every time, and this always works, no matter if it's 1, 2, 3, 4, whatever's in front. But if it's a 1 in front, then you can use this trick, and once you get these values right here, right, then all you got to do is do the plus 6 and the minus 1. So this numerator factors to x plus 6 times x minus 1. What about the denominator? Well, the denominator is another a equal to 1, so I can use my trick. I want it to add to -5, or multiply to -5, add to 4. Well, 5 and -1, if I do 5 minus 1, I get 4, okay? So that tells me, a positive 5 tells me I have an x plus 5, and a -1 tells me I have an x minus 1. Ooh, look at this. Now, before I simplify and cancel, I need to set the denominator equal to 0. So set the denominator equal to 0. X plus 5 times x minus 1 equal to 0. And I do that, I get x plus 5 equals 0. Or x minus 1 equal to 0. And so x is -5 or x is equal to 1. Those are the restricted values. That's what I cannot have. Now, that being said, we can cancel. This x minus 1 factor cancels with that x minus 1 factor. Well, Mr. Clark, you said anything with that plus in there, we couldn't cancel there, right? Well, what's different now? What's holding these two things together? It's multiplication again, guys. So watch out for that. So what does this simplify to? It's x plus 6 divided by x plus 5 as long as x is not equal to 1 and not equal to 5. So the restricted values are 1 and -5, and then it simplifies to x plus 6 divided by x plus 5. Okay? So I hope that this is helpful. Maybe we can do one more. All right? Let's just do one more. Why not? Y to the 4th minus 5y cubed divided by y squared plus 4y minus 45. okay? In the numerator, there's two terms. It looks like I've got two things in common, y's, so y squared comes out, and I have y to the fourth. I'm sorry, y squared minus, I'm sorry, I can pull more than a y squared out. Look, there's 4 y's here and 3 y's there, so I'm going to pull 3 full y's out, and that leaves me a y minus 5. Now in the denominator, this thing, AC method, a equal to 1, I can use my trick. Multiply to negative 45, add to 4. 9 times negative 5, 9 minus 5 gets me 4. So 9 gets me y plus 9, and negative 5 gets me y minus 5. So this is going to go right here. And so I set the denominator equal to 0. I set the denominator to equal to 0, y plus 9 equals 0, or y minus 5 equal to 0. So it means y can't be negative 9, and y can't be 5. And what else can happen? I can cancel, because there's multiplication between those two. Cancel, cancel. And so what do I get? I get y cubed. Let me write my answer all pretty down here. Y cubed divided by y plus 9, as long as y does not equal negative 9 and y does not equal 5. Okay? All right, hopefully this video was helpful.